Okay, excellent. Uh, Welcome to my talk. I hope that you're not all here because of the mistake in the schedule. I hope that some of you are here because they want to see this. My name is Riancho, and I'm the project leader for W3AF. It's web application attack and audit framework. I've been working on this for 2 years and a half. I work at Cybersec. Cybersec is a small consulting company in Argentina. I'm from Argentina also. I'm a programmer, and all the software that I do is coded in Python. Also, W3AF is in Python. I have some background in IPS evasion and networking, and I also perform some research in my job and in my spare time. And sorry for my English, it's not my native language, so I may switch some tenses or stuff. Okay, W3AF stands for Web Application Attack and Audit Framework. It's open source, and it's a little script that evolved into something that's really big. Right now, we have something like 70,000 lines of code. I was working as a web application penetration tester, and I found out that we didn't have a tool, an open source tool to aid us in our work. We only had commercial tools like Acunetics, AppInspect, and all those, but those tools are pricey. We are working in Argentina, and Argentina has no money. And is it true? And well, all the commercial tools cost like, I don't know, $3,000, and our consultancy company didn't have that money. So I started to develop some little scripts. The scripts were just to make my job faster, and at one moment the code development improved really in a steep way, because I had a lot of time. My girlfriend had left me, so I could code like 10 hours a day, and I did. And well, that's how the framework started. Right now I do like 2 or 3 hours a day, and that's shown in the SVN commits. If you guys look up my commits, you see once a day or 3 or 5 times a day, you're going to see SVN commit from me. W3AF is a vulnerability scanner, and it's an exploitation tool. So we are going to find and exploit those vulnerabilities. It's made mainly for penetration testers. We are trying to expand it in a way that's going to be easier to use. So, for example, system administrators can use it. Well, the main features. At any time, just raise your hand if you have a question. Main features. It finds almost all web application vulnerabilities. We have something like 130 plugins. The project is divided in plugins. Think plugins like in Nessus. It's cross-platform, so it works in Windows, in Linux, in macOS, etc., etc. Whenever you have Python, you can run W3AF because it's pure Python. It's written all in Python. And it uses some tactical exploitation techniques that I haven't seen in other tools. For example, we're going to see some examples, so I'm not going to rush myself. We have a GDK and a console user interface. In the talk we had before me, Yanis told us that the console user interfaces are poor and have less features. In this case, it doesn't apply at all because the console user interface does everything that the GDK user interface does. Of course, in the GDK user interface, we have nice graphs and ways of seeing the information that we don't have in the console, but that's something that's expected. Well, okay. We have also web service support, so you can find SQL injections in web services. We have like 10 exploits. These exploits are just a different type of plugin. We can exploit SQL injections, div, misconfigurations, OS commanding, remote file inclusions, and so on. Right now, the focus of our work is to make all the detection work. We have a lot of plugins that are detecting the web application vulnerabilities, and we are focusing on those. We are trying to have the exploits the exploit plugins in order to promote the software, in order to make some research. But what we really need and what we are doing is fixing bugs in the detection stage, in the audit. We also have WML support, so you can scan through cell phone web applications. It's really easy to extend. I have been coding it using the best practices, like object-oriented programming and design patterns and all that. And the plugins don't work just one here and one here. They communicate and they have synergy, so that's something important. Right now we can find vulnerabilities in query string parameters, in post data, in here, okay? If you're scanning a site that has model rewrite or something like that, you can inject SQL injection here and you can exploit it if it's here. We also inject in HTTP headers, in the content of a file that's being posted to the web application. As I already said, we have 130 plugins. These plugins are divided in different types. We are going to get into that. And we are also starting to support the manual analysis of web applications. When the project started, our main objective was to make all the detection of vulnerabilities in an automated way. Right now, we are mixing the manual and the automated methodologies. W3AF is divided in a core and plugins. The core provides the features for making the requests, for the configuration, authentication, proxies, all of that. And the plugins only have the information they need. For example, the SQL injection plugin is rather small. It doesn't have a lot of lines of code. And the plugin doesn't know really if it's injecting in here or in here or in the file content. That's the beauty of the object programming, object-oriented programming. The plugin just says, okay, I want to send to a parameter, I want to send a quote. And the whole framework works in a way that it sends the request, the response comes back, and it's analyzed by the same plugin. Well, the core coordinates the process, and the plugins do the work. There is a knowledge base, just like in Nessus, where all the plugins upload their information, and every plugin has access to every other's result. So we are having plugin communication. And we have eight different types of plugins. These are all the different types. We have the discovery plugins that will find the URLs. They will find the forms, the web services. For example, we have a web spider, something really simple. It follows links and converts the forms and the query strings into objects that are then going to be fused by the Audit plugins. We have an URL fuser. It simply changes an URL. For example, if we have index1.asp, it will try index2.esp, index3, index0.esp. We have a Google spider. We use Goo to spider the site. And we have a Nicto port to Python. It's called Picto. And we have, from these plugins, we have like 40 are discovery plugins. So we have a lot of focus. We have a lot of focus on, sorry. Okay. We have a lot of focus on the discovery stage. We know that if we can't map the application, we can't find the vulnerabilities. That's really important. The discovery plugins are run in a loop. So we have one discovery plugin that finds something. That something is going to be sent as the input for the next one. And if the second one finds more URLs, it's going to send that input to the first one. They are run in a loop, and they are run until no more knowledge about the site is found. So we have that discovery stage that can last almost 12, 16 hours. If the site is really big and the connection is slow, it can last for a lot of hours. And if you enable less plugins, of course, it's going to last less hours. We have audit plugins that are going to find those vulnerabilities. So the discovery plugins found a parameter. That parameter is going to be the input for the audit plugins, and the audit plugins are going to find the vulnerabilities. For example, SQL injection, cross-site scripting, etc., etc. Well, the result of these audit plugins are stored in the knowledge base as vulnerability objects. These vulnerability objects will then be used by the attack plugins in order to exploit that vulnerability and get something out of it. Maybe an operating system shell, or a SQL injection shell, or something like that. We also have grep plugins. These grep plugins will analyze every request and response and find, for example, HTML comments, private IPs, directory indexing, emails from the site. For example, these emails that are found by grep plugins will be reused by brute force plugins. So if you find, for example, joe@google.com, the brute force plugins are going to try Joe and are going to try Joe@google.com in every login that's in the whole site. We also have a password profiling. If you're scanning a bank, the password profiling plugin will create a list of the most repeated words in the whole site. So you're going to have in the password profiling, in the top 3, you're going to have bank and, I don't know, America and, I don't know, money. Okay? So those 3 words are going to be used as passwords for the Joe at Bank of America. And we have like 50 plugins or 40 plugins that just find stuff in the responses. We also have the attack plugins. We already talked about them. They take the vulnerability objects from the knowledge base and they give you a shell. And we have other types of plugins like the output plugins. These output plugins will show you a log on the screen, will write a file for you with a report in HTML or a text file. All that kind of stuff is done by output plugins. And the other ones are less interesting. Mangle is for doing some strange stuff with regular expressions. When something matches the regular expression, it's changed to another thing. Evasion is for IDS and IPS evasion. And brute force, I already told you. So, small demo of this. Okay, this is the graphical user interface. The graphical user interface was developed by Facundo Batista. He has been developing the user interface for 1 year now, or 8 months, 9 months. We have been helped by some usability experts that gave us some tips. And we tried our best, but, well, it looks like this. Okay. We're going to perform a simple scan. We set the target here. Okay, we set the target. We have this. This is the different plugins that we can enable or disable. For example, we are going to enable all the audit plugins. If you want to know what a plugin does, you simply click on it and you see the description. If it has configuration parameters, you can just set them there. If you are really into this, you would want to edit the plugin. You will see the code and all the stuff it does. So we enabled some plugins, we set a target, we are ready to go. We hit start. We see a log of all the things that are happening at this moment. So it's starting with to run some plugins, okay? And at some point in red we see that it found some vulnerabilities. This graph shows a compressed image of what's going on here. We can filter this to show only vulnerabilities. And we go to the results. In the results we see the different vulnerabilities. This is like watching directly to the knowledge base. So we can find, with the framework, found some vulnerabilities that are shown here. And for example, we have this OS commanding, really trivial vulnerability, but nice to show. We have the vulnerability here. We have the description. We know that it was found in the request with ID 43, and that request is shown to us here. This is the request that triggered the vulnerability, and this is the response, the HTTP response. We have a nice way of displaying the sitemap. And we have a little log for all of the requests that are made. Okay, you can analyze this. This is every request that is made by the framework will end up here. Nothing is missed. So if you are doing an audit job or pen testing and you want this, it's really useful. And you also have the exploit section where you have the exploit plugins here, the vulnerabilities here, and if you select the correct exploit, it's going to show up here. You drag and drop, it says something, and then you have the shell, and we are executing with this OS commanding vulnerability. We're executing on the remote server. Like that, we can drag and drop, for example, with SQL map. If we had a SQL injection vulnerability here, we could drag and drop, and something like a SQL injection shell would be shown to us. We don't have time to show every feature. We are going to show something else. This is for the manual section of the framework. For example, this section is a fuzzy request generator that has, how do you say it, Python syntaxes. So if you do something between the dollar signs, you are going to be generating an iterator that's going to generate a lot of requests. We are going to see this. So for those that know Python, this is really simple. We are doing a list of 10 items from 0 to 9, and we are going to be requesting HTTP localhost 0, 1, 2, 3, 4, 5 until 9. So that's it. We send it. We can see all the requests and responses here. They look all the same. But this is the odd one out. But just imagine that you're analyzing, and instead of 10, you have 10,000. You would like to know in an easy way and fast way which one is the odd one out, because you don't want to click 10,000 times these little arrows. So you cluster the responses, and you see that this one is really different. These ones are all the same. So this is the odd one out, and this is a 404. And this is a really cool graph that you can navigate like this. It's clustered by graph-based.
No, what are the numbers?
The numbers are the IDs. The numbers are the IDs of the requests.
And the position is based on size?
The position is based from the Levenstein distance between the responses, the HTTP body responses. The Levenstein distance is the editing distance between two strings, so it compares them like that. The only bad thing about this is that if you have like 5,000 requests and responses, the comparison and the generation of the distances between those strings is rather complicated and takes a lot of time, but we are working on it, and maybe we're going to use the length of the responses in order to generate this graph. Okay, we also have, for example, some encoding and decoding, really simple. I missed some section. Let me exchange 10. Okay, we send all the requests, and for example, we want to compare this one with this one. So this is a visual diff, and you can see that we are comparing two HTTP responses. You can see that this line is the only one that changes, and this is the only change. So this is really helpful when you're doing some SQL injection, something strange. Okay. Oh, fuck. Okay. Some of the interesting features we have are the tactical exploitation features. We have a plugin that will spider archive.org. This site has old versions of the sites. So we are going to spider archive.org and check if those sites that were linked in the past are still in the actual site. We have found that some sites have non-linked sections, and those non-linked sections in the actual site were linked in the past. So that old section will give us possibly a vulnerability. So that's pretty cool. We have also developed a small plugin that will use PHP Easter eggs. Those PHP Easter eggs are generated obviously by PHP, are disabled with expose PHP equal off, but nobody does this. So by having I also have to tell you that PHP Easter eggs change from one version to another of PHP, because one of the Easter eggs shows you all the contributors, and on version 4.1.1 you had 10 contributors or something, and in version 4.1.2 you have 20 contributors. So that page changes. We have a database of Easter eggs, and in that way we identify precisely the PHP version. We also have a really funny thing. It's the Good Samaritan module. One day at job, we were thinking that blind SQL injection could be a lot funnier, a lot smarter, and a lot easier to do. So we said, why don't we help this crippled algorithm that's trying to find things? We're going to help the algorithm. So that's a Good Samaritan, and we're going to see that in a second. So, going to zoom in, zoom in. No, that way. Okay. Okay, great. We're going to be using the console user interface that has some scripts. Scripts are text files that have one line after the other with the same commands that I would be typing in the console user interface, but I can't do it now. It's really a shame. But we're going to see some comments. Okay, we are in the main prompt. We do a MISC settings to enter some configuration menu. We set some parameters. We go to the plugins section. We enable some plugins. We show something. And then, finally, we are exploiting a SQL injection. It's not really important how we are doing it. And what I wanted to show you is the Good Samaritan module. So we are going to help the SQL injection process. So we are trying to enumerate the different databases. So we are seeing in real time how this is working. So I can say something like, this is information, and now it's schema. Okay. Now, just I contributed to the algorithm the word schema, and it was a good guess. I'm just guessing what the SQL injection could be showing us. This was a good guess, so the process continues now from the S. It continues from schema, okay? And that's a way to speed up the SQL injection process. For example, if you get you are watching the process and you see info, you can deduct mention, and you could speed up things a lot. I also worked with some dictionaries in order to make this in an automated way, but I didn't have the time to commit it to the SVN. So in the future, we are going to do this in an automated way, and when the algorithm finds info, it's going to try mention. And
It's just looking at a dictionary?
sorry?
It's just looking through a dictionary?
Oh, well, yes. Looking through a dictionary and guessing, okay? Actually, the dictionary must have some kind of repetition index. So the most common words are on top and the less common words are on the bottom. So I'm going to test for something that it's highly probable to be there. If I have an I can't guess information from that, but if I have info, I can guess information. And this information example is really simple, but in complex words, maybe it's impossible. Okay. But always the same. Okay. We also have a virtual daemon. This is a feature that was born a while ago. But basically, what we do is using Metasploit framework, the Metasploit framework and the payloads in order to attack the remote web server through a web application. So we are going to use the Metasploit framework in a way that's going to be connected with W3AF, and W3AF is going to send the payload to the remote server, and the remote server is going to execute it. So I coded a Metasploit plugin that connects to the virtual daemon that I run and sends the payload. Then the virtual daemon is it's run by W3AF as I already told you, and it will, depending on the target side, it will create a PE, a portable executable for Windows, or an ELF for Linux. What it does, it takes the payload and it adds the headers for the portable executable and send it to the remote server. Once the executable is there, it will run, and normal communication between the Metasploit framework and the remote web server is done. So the Metasploit framework sends a payload. This payload is cached by the virtual daemon. The virtual daemon sends through the web application vulnerability the portable executable to the web application and executes that file, and that file is going to connect, for example, connect back to the Metasploit framework, and hopefully provide something like a reverse shell or a bind shell. I really tried this because I wanted to provide a reverse VNC connection, but I failed. I wasn't able to make that work. But things that really work are reverse shells and Meterpreter and that stuff from Metasploit. After some time, the guy from SQL Ninja took this idea and made it work. Actually, it was quite fun because I started with this because I saw something in SQL Ninja, and I said, "Oh, but I can use it to make this." I tried to make this. I failed to make it work with VNC, and the other guy from SQL Ninja make it work with VNC. This is the good thing about open source and this kind of community that contributes. We also have a W3AF agent. All this stuff is advanced exploitation. We are doing this because we can and because it's fun. The W3AF agent started with the idea of doing what the Core Impact tool does. These guys from Core Impact are really slick, and they did a cool thing called syscall proxying. I tried to do it and also failed, so I changed my mind and started to do this. The W3AF agent is a VPN that connects back from the remote server to the attacking machine, and you have complete access to the local area network of the remote web server where this is run. So in the attacker machine, you are going to have a SOX proxy listening, and every connection that's made through the SOX proxy is going to be routed through the remote web server and going to be routed, for example, to a secure shell server in some DMC. So W3AF, after exploiting a web application vulnerability, will send the client. The client will perform a reverse connection to the server, and somebody using a SOX client through the server will do a connection to a secure shell server in the remote network. Things that don't work in this agent are UDP traffic, raw sockets, and sniffing. UDP traffic is something that at least I don't know. Can't be routed through SOX proxies. And things that won't work are raw sockets and sniffing because it's a VPN and we are connected that way. What we are doing about Web 2.0? This is really hard because analyzing JavaScript is hard. It's really hard. We have tried with different approaches. We tried with different ways of analyzing. We also tried static analysis of JavaScript that was the worst idea ever. And because JavaScript is so strange and can change, and it has different versions and implementations for different browsers, and it's really a mess. So what we are doing now is we have a way of training the framework. You are going to be using a plugin. It's called Spider-Man. Spider-Man is going to listen on a port using a proxy server, and you have to configure your browser to browse through Spider-Man. Spider-Man will catch all the requests and responses and create the fusible objects, so Audit plugins can find the vulnerabilities. So this is a manual solution. You have to browse through all the site using your browser and the specific proxy. It works, okay? So you can enable 10 discovery plugins and Spider-Man, and when the whole process ends, you're going to be clicking on the web application. It's going to find all the links and all the JavaScript stuff. We also support JSON, so that's going to work. And that's about 2.0. Okay, I want to talk about the future of this tool. We want to have some JavaScript automation. It's hard, but we know we can do it. We need, and we are working on it, we are working on a more stable core. Like 6 months ago, if you were running W3AF, you almost knew certainly that it was going to crash. But right now, you can run it from the start to the end and do all your stuff, and most likely in 95% of the cases it won't crash. That's a really good thing. We are working on less false positives and negatives. That's something really important for us. We are working on it, and in the future we will have a really lengthy list of attack plugins. We also need to have a better GDK user interface. We need to visit this usability experts like 10 more times. This guy is really good and tells us a lot of good stuff that we usually don't see in open source unless in security applications. So we are going to dig deep into that. Right now, the report generation for management is none. It's a tool for penetration testing, for penetration testers. So you're going to find a lot of resources about that. In the future, we will create an output plugin for really nice and with graphs and all that for management. And we also need a long description for all the vulnerabilities. Right now, as you saw 10 minutes ago, we have only a short description that says, and SQL injection was found on this parameter. But we need to extend that in order to be able to make the tool be used by system administrators that may not know what a SQL injection is. Okay. Here's the project site. We have 2 mailing lists, users and developers. I'm the project leader. I'm going to be hanging around here. So if anyone has any questions, make them. If anyone wants to contribute, do it, please. Please do it. We have like 10 contributors from all over the world, but we need more because we are perfectionists, and we really want to do something useful for the community. It's open source. You can read all the code. If you read all the code and find something, report the bug. I really love to fix bugs. I've been for 6 months. All what I'm doing with this is fixing bugs, and I know that's That sometimes that sucks because the users don't see that the project is growing. They don't see some new features, but they see that it's going to be stable and it's going to be a better project. These are my sponsors. I work here, and these are really cool people. Conclusions: frameworks are the future. Use it. Send me an email. Report a bug. Have fun. And it's open source. You guys should contribute. And that's it. Any questions? Questions?